This is part 4 of our lesson on reducing expressions. So our very last example says log base 6 of x cubed minus 9x squared plus 26x minus 24 minus log base 6 of x squared minus 4x. So I notice when I look at this, I have two logs with the same base, but that they have different arguments, and they are being subtracted. So when you are subtracting two logs with the same base, you can combine them into one by dividing their arguments. So this is log base 6 of x cubed minus 9x squared plus 26x minus 24 divided by x squared minus 4x. So I would like to see if this reduces, because the question asks me to reduce. There is a chance that maybe this would divide in evenly, but I think it's unlikely. So I could try to just divide this into this, but I would likely end up with a remainder. So instead, I would like to factor my numerator and then factor my denominator. So I'm going to take that numerator over to the side, and we will see what we can do. So I have x cubed minus 9x squared plus 26x minus 24. So when I look at this, I see that it has 4 terms. The first thing I do is look to see if it has a common factor. Unfortunately, they don't all have an x, and they don't all divide by the same number. Then I would look to see if I could factor in pairs by grouping. If I were to group the first two together, I could take out an x squared, and I would get x minus 9. I don't see how I'm going to get an x minus 9 out of this, considering this is bigger than that. So I don't think that grouping is going to work. So the only other option I have at this point is the factor theorem. So I'm going to make a list of all of the factors. I'm going to divide the factors of the last term by the factors of the first term. So that means factors of 24 would be 1 and 24. 2 and 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 4 is 6. 5 does not divide in evenly, and then 6 takes me to here, and then that means we've covered all of our bases. First term, thankfully, is just a 1. So that means my list of possible factors are plus and minus 1 divided by 1, which is 1, 2 divided by 1, which is 2, 4 divided by, sorry, that's 24, not 2 and 4. So 24 divided by 1 is 24. 2 divided by 1 is 2. 12 divided by 1 is 12. 3 divided by 1 is 3. 8 divided by 1 is 8. 4 divided by 1 is 4. And 6 divided by 1 is 6. And like I said, they could be positive or they could be negative. So what I want to do is just pick some numbers and test until I find one that gives me a remainder of 0, and then I'll know that I found a factor. So I'm going to start, I think I'm just going to start with 1, although I'm looking at this and I'm not thinking 1 is going to work. So if I have 1 to the power of 3 minus 9 times 1 to the power of 2 plus 26 times 1 minus 24, I get negative 6. That's not a 0. I need to keep going. I could try negative 1. Negative 1 to the power of 3 minus 9 times negative 1 squared plus 26 times negative 1 minus 24 gave me negative 60. That didn't work either. I could do 24. I think I might try 2. All right, 2 to the power of 3 minus 9 times 2 squared plus 26 times 2 minus 24, woohoo, is a 0. So I found one that gave me a remainder of 0. When you get a remainder of 0, that means it's a factor. So 2 isn't the factor. It's what I made equal 0 that gave me 2 that would be the factor. So I know x is 2. So x minus 2 is my factor. So that means I know that this, the first bracket, is going to be x minus 2, and then times something. I need to figure out that something. In order to do that, I'm going to do some long division. So I'm going to take x minus 2 and divide it into x cubed minus 9x squared plus 26x minus 24. How do I turn an x into an x cubed? We multiply by x squared. I get x cubed minus 2x squared. I subtract. X cubed minus x cubed is 0. Negative 9 minus negative 2 is negative 7x squared. 26 take away nothing is 26x. And negative 24 take away nothing is negative 24. Okay, up next, how do I turn an x into a negative 7x squared? I multiply by negative 7 and x. So negative 7x squared plus 14x. I got that by multiplying both of these by negative 7x. So negative 7 minus negative 7 is 0. 26 minus 14 is 12x. And then negative 24 take away nothing is negative 24. Last up, I need to multiply by 12 to turn that into a 12x. And then 12 times negative 2 is negative 24. If I subtract, 12 minus 12 is 0. Negative 24 minus negative 24 is 0. The remainder is 0, which is what it's supposed to be if this is a factor. So that means that this expression here is x minus 2 times x squared minus 7x plus 12. Now, I need to see if this will factor any further. I do notice that it does not have a common factor. That first term does not have a coefficient other than a 1, which means I can use the shortcut. All I need to do is find two numbers that add to negative 7 and multiply to 12. So 1 and 12 would not work. 2 and 6 would not work. But 3 and 4 would work, especially if I did negative 3 and negative 4. That would add to negative 7, and a negative times a negative does make a positive, so we are okay. So that means this is x minus 2, and then x minus 3, and then x minus 4. You can use decomposition, but I am using the shortcut because there's nothing in front of that x squared. So I have factored my numerator. We are going to put that in place of my numerator. So this is log base 6 of x minus 2, x minus 3, x minus 4. On the bottom, I have x squared minus 4x. I'm going to go and factor that off to the side here. So I have x squared minus 4x. I have two terms. First thing I look for is a common factor. I do notice they both have an x. So x squared divided by x is x. Negative 4x divided by x is negative 4. It does look like a difference of squares. If it didn't have the x, it would be a difference of squares, but because it has the x, it has a common factor instead. So this is just x times x minus 4. So that means my denominator here is x times x minus 4. Now, we wanted to reduce. So I do notice that in the numerator and the denominator, there is an x minus 4. So I can divide those out, and I would be left with log base 6 of x minus 2, x minus 3 over x. Whew, all right. That was a very long lesson today. Lots and lots of parts. This is my final answer, by the way. We could do a restriction if we wanted to, but we haven't talked about how to do restrictions on things where you have multiple x's. We've only really done ones that are linear, so that just have x and no exponents. Okay, so for homework today on this, there is the reducing expressions practice. I would definitely recommend doing question number 1. right? There's lots of good different types of practice there. There's a polynomial, a log, an exponential, and a trigonometric function. If you're looking for a little more problem solving, right, you might want to try definitely question number 3. You can work on question number 2. It's got some slightly more complicated factoring, but minimum, I would like you to work on question number 1. So if you do all of it, awesome. But if you're not going to do all of it, then please at least do question number 1. All right, have a great rest of your day.